Okay, so next let's turn our attention to the cotangent function. Let's see what that's going to look like. Recall that we had said that for the cotangent function, y equals, there's a different color here, y equals the cotangent of x, that our domain was going to be the set of all x such that x is not equal to whole number multiples of pi. Now that's going to be important to us because that is where we're going to get vertical asymptotes. And so let's go through and let's just mark out a few points here along our x-axis. We want to go from 0 to 2 pi in a way that was similar to what we did when we were dealing with tangent. So we're going to go from 0 to 2 pi. You'll see why we're starting there instead of on the left-hand side of the x-axis, although we can plot that. So I'll make each of these marks at pi over 2. Here's pi. Here's 3 pi over 2, so that makes this 2 pi right here. And we can keep on going outside of that. I might just add one extra half of a period or so, or one extra. What's going to happen? Well, we can say some of the following things. That x equals 0, right, that's undefined. So I'll make a little table here, probably just easier to follow. So for my value of x equals 0, we've got a vertical asymptote that's going to happen. We could say that at pi over 2, the cotangent itself is equal to 0. So this graph will pass through the x-axis at pi over 2. If we get out to pi, we see that we've got another vertical asymptote. And let's see, well, what happens in between? Well, what would happen at pi over 4? A cotangent of pi over 4 is the same thing as the ratio of cosine over sine, but that's just going to be equal to each other, right? So that'll be equal to positive 1. So at pi over 4, we're going to get a value of y equals 1. 3 pi over 4 is another 1/4 of the way kind of mark, right? 3 pi over 4, what happens there? Well, at 3 pi over 4, since it's cosine divided by sine, and cosine is negative but sine is positive, we're going to get negative 1 for y at 3 pi over 4. And if we follow this pattern right here, we're going to see that this graph cotangent comes down along the vertical asymptote through the points pi over 4, 1, pi over 2, 0, and 3 pi over 4, negative 1, and then goes towards negative infinity. And just like the tangent function, this cotangent function is also going to repeat itself. So quarter-way marks, it's going to be at 1. Halfway marks, it's going to be at 0. 3/4 of the way, it's going to be at negative 1. It's going to follow this pattern each step of the way, no matter how many of these vertical asymptotes we put. Here's another one here, 3 pi over 2. The function's going to tend towards, let's see, quarter of the point 1. Halfway through, it's going to be at 0. 3/4 of the way, it's going to be at negative 1, and then the rest of the way, it's going to go towards negative infinity. And this pattern will just simply repeat over and over again like wallpaper. So, could we say, well, identifying our vertical asymptotes in this case are occurring at x equals multiple values, whole number multiple values of pi, x equals n pi, right? So x equals any n times pi, right? And of course, as you see right here, we could say it's 0, pi, 2 pi, 3 pi are all representative values here as we go off to the right. If we went off to the left, we'd see negative pi, and again, a whole number or integer multiples of pi representing our vertical asymptotes. All right, what else can we say? Well, the range is all real numbers. And if we're looking for the period of the function, just like we did with tangent, we'll note that each of these patterns repeat every pi units, and that is our period of this function. And that's true within every interval right here. The period is naturally equal to pi. The range all real numbers, there's no amplitude like the others, so this is it. This is what this graph is going to look like, at least at the basic level. We'll go through and we'll make some adjustments to it as we go.